Try to remember your second birthday. Go on. Really try. Nothing comes back. Not the cake, not the room, not one single face. And you have probably been told why. The memory was never really saved, or something inside your head grew over it and wiped it out. That is not what the evidence says. The memory was saved. You just can't get to it. Sigmund Freud gave this a name in the late 19th century, and he called it infantile amnesia. Everybody has it. Every person you have ever met is missing the same stretch of their own life. And almost nobody finds that strange until somebody points it out. Memory runs through a curved structure deep in your brain called the hippocampus. It is small and curved, and it sits deep behind your temples. In a baby, that structure is doing something extraordinary, building brand new brain cells at a rate it will never manage again. And in 2014, a team publishing in the journal Science showed what that costs. Every new cell that wires itself into the circuit disturbs the wiring that was already there. They tested it in mice, in both directions. When they raised the rate of new cells, adult mice forgot things they had already learned. And when they slowed that rate down in infant mice, those mice held on to their memories for longer than they ever should have. It even held across species, because animals that are born with most of those cells already in place don't show infantile amnesia at all. So the story wrote itself. Your brain grew, and the growing wrecked the record. And that is the version most people have heard. And it's half right. The half that's wrong is the important half. Because there are two very different ways to lose something. It can be destroyed, or it can still be sitting there, behind a door you can't open. In 2018, the same laboratory that first blamed those new neurons went looking for which one of those had actually happened. They tagged the exact cells that switched on while an infant mouse was learning something. Then they waited until that mouse was fully grown and had forgotten the whole thing. Then they switched those cells back on with light. The memory came back, up to 3 months after training, long after every normal test had said it was gone. It hadn't been destroyed. It had been sitting in there the whole time. And the people who showed that the memory survived were the same people who first said the growing brain wipes it out. Now, there is an obvious objection here, which is that firing a laser into a brain isn't the same thing as remembering. So try it without the laser. A separate lab, working with rats, taught them something during the window when infant memories vanish. The memory faded right on schedule, and by every test they had, it was gone. Then, much later, they gave the animals a reminder, just one piece of the original experience and nothing else. And the memory came straight back, strong and specific, and this time it stayed. Their conclusion, in their own words, was that early memories are not lost, but remain stored long-term. And it's not only frightening memories, because the same thing works for something as plain as remembering where an object used to sit. There is a name for a memory that's physically present but won't answer. Researchers studying a different kind of memory loss called it a silent engram. An engram is the physical trace a memory leaves behind in your cells. A silent one is complete, like a bulb with its filament intact and the wall switch torn out. It just won't answer the ordinary cues anymore. A third laboratory, working separately from both of the others, reached the same verdict and called infantile amnesia a reversible retrieval deficit. Reversible. That's their word, not mine. And then that same group found something stranger. Your brain has cells called microglia, and one of their jobs is trimming the connections between your neurons. When they blocked those cells during one specific window in infancy, the mice didn't develop infantile amnesia. The forgetting simply didn't happen. Which turns the whole thing around. Forgetting your first years isn't damage. It's something your brain does on purpose, inside a window, with machinery built for the job. But every single one of those studies is an animal study. So in 2025, a study in the journal Science tested this in human babies. They put awake babies into a brain scanner and showed them pictures they had never seen before. When the hippocampus lit up while a baby looked at a new picture, that baby was more likely to linger on it later. And how long a baby looks is how you measure memory in someone who cannot talk yet. From about 1 year old, babies were already recording. The machinery was running. Now the honest part. That test ran across about a minute. A minute isn't a childhood. The study shows that a baby can record, but it doesn't show that what they recorded is still in there 20 years later. The authors were careful about it, writing that mechanisms after encoding, which make infant memories hard to retrieve, may be more responsible. Maybe. There is older human work pointing the same way. Across the first year and a half, babies hold on to what they learn for longer and longer. The classic experiments tied a ribbon from a baby's ankle to a mobile above the cot so that kicking made it move. Babies only a few months old could hold on to that for as long as 2 weeks. Though researchers still argue about whether that kind of memory runs through the hippocampus at all. And the researchers checked something clever. The older babies weren't learning it any better in the first place, they were simply keeping it for longer. Which means the thing that changes as you grow isn't the recording, it is whatever happens to the recording afterwards. And here is the line that nobody has crossed yet, because every recovery, every memory ever brought back has happened inside a rodent. The scientist who ran the baby scanning study said it plainly. We can't do that in humans, but that is the best evidence that the memories are there. So nobody has proved any of this about you. What has actually happened is that the whole field moved. A 2022 article in the journal Hippocampus wrote that the old explanations are not correct or incomplete, and that early memories, far from being lost, can be brought back. And a recent review went further, arguing this is not special to babies at all. Across a great deal of memory loss, the authors say, most of it can be restored with the right cue. So think about what that means for the blank at the start of your life. It probably isn't a hole. It's more like a room with no handle on your side of the door. And you are using what is inside that room constantly, every hour of every day, without once being able to picture where any of it came from. You learned to walk in there. You learned your mother's face in there. You learned the sound of your own name and the shape of the people who were safe and every rule of the language you are thinking in right now. None of that came back to you as a memory. All of it came back to you as you. The popular version of this story says that the baby in your old photographs was taken apart to build you, and that the person who came before had to be destroyed. The evidence points the other way. Nobody was destroyed. The record just went quiet. Nothing down there was thrown away, like a book still on the shelf in a room you can't find. It was just put somewhere your grown-up mind has no key for. You aren't standing on top of somebody who got erased. You're still that person. You just can't hear them anymore.